Welcome everyone. In today's video, we are going to solve more examples on standard deviation and variance. So we have sample data and population data. And in the example one, we have calculating for standard deviation and variance for sample data. In example two, for population data. So let's go through the example one, and then after that, we go to the example two. So from the example one, it states that sample of patients body temperature in degrees Celsius, and we have body temperatures of 1, 2, 3, 4, 5. 5 observations or 5 body temperatures for 5 patients. So before you can calculate for the variance for sample data, we first have to put down the variance for sample data formula, for which it is summation of x minus s bar, which is the mean, all squared, divided by n minus 1. From the data, you know that you have to calculate for mean before you can get the variance. So calculating for mean, this is a raw data. So you use the formula for calculating for mean in raw data. So the mean will be summation of x divided by n. So first one, you have to add or sum all the observations together. Then you divide it by the number of observations. So how many observations do you have? 1, 2, 3, 4, 5. It means n is equal to 5. Then let's sum all the observations together. So it will be 36.2 plus 35.4 plus 36.7 plus 35.5 plus 37.2, all divided by 5. So the numerator, when you compute it, you get 181 divided by 5, which will give us 36.2. So the temperature is measured in degrees Celsius. So you bring degrees Celsius. So now we have our mean to be 36.2 degrees Celsius. But you have to calculate for deviations first before you substitute it into the formula. The deviations is the numerator. So for the deviations, you take each variable or each observation and you subtract the mean from it. Then after that, you square the answer you get. So let's calculate for the deviations. So the deviations is s minus the mean squared. So let's start from the first observation. 36.2 minus the mean, which is also 36.2, and you square it. So it will give you 0. Then the next one is 35.4. 35.4 minus 36.2, and you square it, which will give you 0.64. So the next one is 36.7. 36.7 minus 36.2, and you square the answer, which will give you 0.04. Then the next one is 35.5. 35.5 minus the mean, which is 36.2, squared, to give you 0.49. Then the last one is 37.2 minus 36.2 squared, which will give you 1. So after calculating for the deviations, in the formula we have summation of the deviation. So it means that when you get the deviations, you add all of them or you sum all of them together so that you complete the numerator. So the summation of x minus x bar squared will be 0.0 plus 0.64 plus 0.04 plus 0.49 plus 1, which will give you 2.17. So this is the summation of the deviation. Now, in the formula, we have n minus 1 for sample data or sample of the patient. So n minus 1. So the n minus 1 means the number of observation minus 1. So you get 5, the n will be 5 minus 1, which will give you 4. Now let's substitute everything into the formula. So the top or the numerator, we have 2.17 divided by n minus 1 gave us 4. So this one will give us 0.5425. So right now our variance is 0.5425. Let's calculate for standard deviation. Standard deviation, the formula for standard deviation is simple when you have the variance, because the standard deviation is the square root of the variance. So standard deviation is square root of variance. And you have the variance to be 0.5425. So standard deviation will be square root of 0.5425, which will give us 0.737 in degrees Celsius. Make sure you bring the units. So right now we have our variance to be 0.5425, and then the standard deviation to be 0.737 in degrees Celsius. So in all, we calculated for, or we did sample of patients or sample data when you are calculating for variance and standard deviation, for which we have 5 observations of 5 patients' body temperature in degrees Celsius. So for calculating for the variance, I said first you put down the variance for variance sample data formula, or the sample data for variance. You put down the formula, which is summation of s minus the s bar all squared divided by n minus 1. So in the formula, you are supposed to calculate for mean, and the mean is summation of x all divided by n. And we got the mean to be 32.6 degrees Celsius. After getting the mean, you do the deviations. The deviations is the numerator. So for the deviations, when you pick each of the observations, you subtract the mean from it and you square the answer, for which we got all the answers here: 0.64, 0.04, 0.491, and then we sum all the deviations. So the summation of the deviations gave us 2.17. And then we have the observations, which is n to be 5. But in the formula, you are supposed to subtract 1 from it when you're calculating for sample data. So when you subtract 1 from it, you get 4. So then you put it in the formula. Variance is equal to the deviation, summation of the deviations, which is 2.17 divided by the number of observations minus 1, which is 4. And you compute it, you get 0.5425 in degrees Celsius. After that, you come to calculate your standard deviation. For a standard deviation, the formula for standard deviation is the square root of the variance, and we have our variance to be 0.5425. So the square root of the 0.5425 will give you the standard deviation, for which we had 0.737 degrees Celsius. Now, there's another example here for which we are going to calculate for population, or when the data is from a given population instead of sample of patients or sample data. So the difference in population and sample data is very simple. You go by the same way, but then there's a small little change in the formula. But now let's go through it step by step. We have the diastolic blood pressure for a population of patients to be 80, 95, 74, and 65. For this one too, you are supposed to put down the variance formula for population, for which you are going to get summation of S minus S bar squared all over n. So the difference is that when you are doing for sample data, you subtract 1 from the number of observations. But this one, you do not subtract anything from the number of observations. Now, here too, we are supposed to calculate for our mean. So the mean for this data, which is 80, 92, 74, and 65. The mean will be summation of x all over n. So you sum all the data given and you divide by the number of the data present. So right now the sum of the data will be 80 plus 92 plus 74 plus 65 divided by the number of observations present, which is 1, 2, 3, 4. So first you compute the numerator, then you divide by the. So you get 311 divided by 4, which will give you 77.75. It is in millimeters of mercury, which is mmHg. Now you have your mean. So from the formula, you're supposed to calculate for mean. And when you get the mean, you're supposed to calculate for the deviations as we did for the sample data. So the deviations, as I said earlier, when you pick each observation or variable, then you subtract the mean from it, then you square it. Now let's go to the deviations. The first observation is 80. So 80 minus the mean, which is 77.75. Then you square it, which will give you 5.063. Then the next one is 92. So 92 minus 77.75. Then you square it, 14.25. The next one is 74. So 74 minus 77.75. Then you square the answer, 14.063. Then the last one is 65. 65 minus 77.75. Then you square the answer, 162.563. Now, the formula, it is stated that we are supposed to sum all the deviations. So this is the deviations. You are supposed to sum all the deviations. It means 5.06, you sum from that part up to the last number. So this one will give us. So the summation of the deviations will give us 195.939. So this is the summation of the deviations. It means we are done with the numerator. Now, the denominator for population data, you are not supposed to subtract anything from the number of observations. So n will be 1, 2, 3, 4. Then you substitute these findings into the formula. So the variance will be 195.939 divided by 4, which will give you 48.985 in millimeters of mercury, mmHg. Squared, yeah. Now, we are going to calculate for the standard deviation. The standard deviation, you are supposed to square root the answer you had in the variance, because the formula for standard deviation when you have the variance is square root of the variance. Now we had the variance to be 48.985 in millimeters of mercury squared. So square root of 48.985. The standard deviation will be 6.999 in millimeters of mercury. All right. So this is how you go about when you have sample of data in calculating of variance and standard deviation and population data. So let's go over everything that we did. So we said that when you're calculating for variance and standard deviation in sample data, first you put down the variance or sample data variance formula, which is summation of the deviations, which is S minus the mean all squared divided by number of observations minus 1. Then from the formula, you're supposed to calculate for the mean. When you get the mean, you subtract the mean from each of the observation present. When you're doing that, what you're doing is that you're calculating for the deviations. When you're done with the deviations, then you sum all the deviations. Summation of the deviations gives you the answer for the numerator here. Summation of the deviations give you the answer for the numerator. After that, you substitute it into the formula because we have our n to be 5, and then you subtract 1 from the n. That one will give you the variance. After that, the formula for finding standard deviation is equal to square root of the variance. So when you get the standard variance, you square root the answer, then you get the standard deviation. All right. Then let's go to the population. The difference in population and sample data is that in the formula of the variance for population, you don't subtract anything from the number of observations, but for sample data, you subtract 1 from it. So here, first you put down the variance formula for population data. Then you calculate the mean, because mean is required in the deviations. So you calculate for the mean, for which we calculated for it and we got 77.75 millimeters of mercury. Then we come to calculating or finding the deviations. For the deviations, as I said, you pick each of the variable and then you subtract the mean from it. When you get the answer, you square the answer. Then after finding the deviations, you sum all the deviations, which it's 195.935, and the number of observation n is equal to 4. The number of observation for population, you don't subtract anything from it, so you substitute it straight into the formula, for which we did that, and we got the variance to be 48.984 millimeters of mercury squared, because the variance is a squared and then you come to the standard deviation. The standard deviation, you don't square it, but rather you take the square root of the variance. Square root of the variance. So the square root of the variance, we have 48, square root of 48.985, and then you get 6.99 millimeters of mercury.